So let's take a look at how we might use the Science DMZ model to support a very large-scale data repository that serves data to a wide variety of scientists at multiple different geographically distant locations. So in this case, a single DTN isn't going to cut it. We need a large set of DTNs because we're going to be serving multiple remote DTNs simultaneously. And in fact, if we're going to have a large number of parallel DTNs, it's usually a good idea to deploy parallel network pipes as well, parallel network entry to the building or facility, in some cases even provider diversity. So we're in the realm now where single pipe deployments and any single choke point or single point of failure is just not going to work. We need to be able to take portions of a big data service like this down to work on them if we need to patch machines or if a DTN fails or something like that. We have to be able to remove it from service, keep the rest of the data service up, fix whatever is broken, and add that portion back into the functioning whole without taking the entire data service down. So this has an impact on tooling, has an impact on architecture, has an impact on the design of the whole data service. But if we look at the way this works, we have this large-scale data service switch plane, a big data transfer cluster connected to it. The data transfer cluster front ends this big storage system, and all of that is in the Science DMZ, and that's as it should be. All of this is a part of the data path for wide area data transfers, and so it's engineered for performance in the same way that a small Science DMZ would be engineered for performance. It's just scaled up to accommodate the data transfer load necessary for putting all that data on the wire and getting it out to all of those researchers. So we instrument it with Personar to ensure that we have easy access to fault isolation and we can run regular tests to make sure the infrastructure is functioning correctly. But all of this is part of a single big Science DMZ to support a large-scale data repository for something like, say, the LHC experiments or a large-scale climate data archive or something of that scale.